This is a recording for section 12.4, the normal distribution. So basically, we take our sample, right, and we construct a very large sample, and we construct a histogram, and we sort of decide the histogram shape. Right, and if we look at this random sample of 100 men and we look at their height, you can see that this is sort of this symmetric, and so we call this, and we have the histogram for the sample, but then we make a curve, we smooth out the curve for the population. So as the sample size increases, right, it will become more and more symmetric, right, and you can see in this, right, as the sample size gets large, it begins to then smooth out, right? These bars become so little, right, that it becomes smooth in a sense. So there are distributions like heights and IQs and many things that we know actually have this sort of shape, which is called the normal distribution. So if we see this bell shape, you should be thinking about the normal distribution. And the mean is right there in the middle. For a symmetric distribution. In fact, that's actually the mean, median, and mode. But all of these three shapes here are normally distributed. They're these bell shapes. However, they have different standard deviations, and when it's close together like that, that just means a smaller standard deviation. All the data values hover closer to the mean. Whereas if you look at this one, the data values are more spread apart. So this graph is one where the standard deviation is larger than this one. Okay. So we often want to know, like for that height, for example, we want to know, what percent of men are taller than, say, 70 inches, right? That might be something we are interested in. So we actually have ways of determining that, right, based on this normal distribution if we know the mean and the standard deviation. What we can say is that approximately 68% of the data values fall within one standard deviation of the mean. So that means one standard deviation in both directions. So you can see that here, one standard deviation to the right and to the left, that represents 68% of the data values. This is called the 68, 95, 99.7 rule. So the second percentage is 95, and 95% of all data values fall within two standard deviations from the mean. So you can see that that's right here. So if we add and subtract two standard deviations both directions from the mean, we expect 95% of data values to fall there. And then the third percentage is 99.7, and that's three standard deviations. So virtually all data values will fall within three standard deviations of the mean. Only 0.3% of data values will not fall within three standard deviations. So you need to know these percentages: 68, 95, 99.7. So for example, the resting heart rates for a sample of individuals are normally distributed. When you see this normally distributed, you should automatically draw a bell-shaped curve, right? And below it, put an axis like that. Are normally distributed with a mean of 70, and the mean goes smack dab in the middle, and a standard deviation of 15. Between what two rates do approximately 68% of all heart rates lie? So remember, the rule is 68, 95, 99.7. So 68 is one standard deviation, 95 is two standard deviations, and 99.7 is three standard deviations. That's from the last slide. So the first question says, between what two rates do 68%? So that's one standard deviation, because that's our first one. One standard deviation in both directions. So we take our mean, which is 70, and we add 15, and we subtract 15, to get 85 and 55. So 55's over here and 85's over here. So we can say that this is 68% of all data values fall between 55 and 85, which is heart rate, so that's beats per minute. Beats per minute. Between 55 and 85. Between what two rates do 95% and 95%, remember, is 2 standard deviations in both directions. So we take our mean of 70 and we add 15 twice to get 2 standard deviations, so that should be 100. And then we subtract 2 standard deviations, so that should be 40. So between 40 and 100 beats per minute. So again, if any normally distributed, you should draw the curve 40, 100, and that is 95%. And the last one says between what two rates do 99.7%, and that's 3 standard deviations. So we're going to add 3 standard deviations to our mean. 30, 45 should give you 115. And subtract 45, which will give you 25. 25 to 115 beats per minute. So 99.7% of heart rates lie between 25 and 115 beats per minute. So I'm certainly hoping that leftover 3.3% is not below 25 beats per minute. So over here in our picture, right, between 25 and 115, that's 99.7%. So not all distributions are normal. You have to decide that it's a normal distribution before you would use these rules. Different distributions have different methods to find the percentage. Like if a distribution is going down to the left, that's actually called skewed left. You would use a different procedure rather than this normal distribution. The normal distribution is only for bell-shaped curves. Male adults' heights in North America are approximately normally distributed with a mean of 70 inches and a standard deviation of 4 inches. Find the height that is 2 standard deviations above the mean. Well, the mean is 70 and the standard deviation is 4. So we would just add 4 twice. So that is 78 inches. Find the height that is 1 standard deviation below the mean. So we take 70 minus 4, so that's 66 inches. And 50% of all males should be taller than how many inches? Well, if you know the mean here is 70 inches, you know that that marks 50%. So it should be 50% taller than 70 and 50% lower than 70. So, all right. 50% taller than the mean and 50% lower than the mean. The resting heart rates for a sample of individuals are normally distributed with a mean of 70 beats per minute and standard deviation of 15. So this is that same data as before, but we're going to be asked about different percentages. Find the percentage of heart rates less than 70. So we have 70. We want the percent less than 70. When you want the percent, you should shade it. And the second you see this normally distributed, you should draw the bell shape and label the mean. Okay, so we know that this is 50% of data values less than 70. Between 55 and 85, so we would have 70 here in the middle, and we mark 55 because it's less than 70 and 85 over here, and this is again exactly one standard deviation this way. If you subtract 55 and add 55, so we know that we want this, and one standard deviation in our rule is 68%. So they're not all going to be this straightforward, as we will see in the next examples. Just keep in mind it's 68, 95, 99.7. Okay, so part C, it says again, we have the mean to be 70. It's normally distributed, and we want to find the percentage of heart rates between 70 and 100. So again, I would recommend shading the percent that you're interested in, so you can see that it's going to be less than 50%, right? Even just knowing that will help you to determine what to do, right? So between 70 and 100, if you add the standard deviation twice, all right, to standard deviation. So you can see that that 100 is 2 standard deviations above the mean. We know that 2 standard deviations is 95%, but I know that 95% means 2 standard deviations in both directions is 95. So I'm not interested in this part over here between 2 standard deviations from 70 will be 40. This whole thing right here between these two values of 40 and 100, that's 95. That's 2 standard deviations. So you're actually going to have to cut that in half because you only want the second half. So you would have to do 95 divided by 2 to get that percentage, which would be 47.5%. Which you would know that 95% doesn't even make sense based on your picture, because half of the underneath the curve is 50%, right? So that makes way more sense. The second one says between 55 and 100. So let's mark our 70. I'll put 100 over here. We'll put 55 over here. And again, I wouldn't get so hung up on the spacing. It doesn't matter as long as the percentages are labeled right. And we want what percent? So we want this. Here you can see again 70 plus 15 plus 15 is 100. So this over here is 2 standard deviations, but I only have half again. But this over here, 70 minus 15 is 55. So this over here is only 1 standard deviation. Okay, so you're going to have to find those two areas separately and then add them together. So, right, this from here to here, right, that's our 95 divided by 2, our 47.5, right? But that's only that region. But you don't want to do that on the other side because it's not 2 standard deviations on the other side. This right here is only 1 standard deviation, and we know, but we only have half because we're only looking at the left half. We're not going over to the right half. This is 68 divided by 2, which is 34%. So the total shaded region, 34 plus 47.5. If you add those together, that's 0.51, 81.5%. 81.5% of all heart rates should be between 55 and 100 beats per minute. We'll go ahead and do the last 2 parts in this recording. What percentages, find the percentages less than 55. Again, we take our Normal distribution, we mark 70 because that's our average. We want less than 55. So again, you shade this. So there is a couple different ways of doing this, but you can see that the answer is going to be way less than 50%. You can see that first figure out how many standard deviations away. That's if we subtract 115 again from 70, you can see that 55 is one standard deviation away. We're still messing around with this standard deviation of 15, so it's one standard deviation. But what you know is between one standard deviation in each direction, that all of this here is 68%, right? Is what you know. But you want this region over here. So what you're going to have to do is you can mess, there's a couple different ways, but what jumps out at me is to know that all of this is 50%, and I know I can find this right here between these two values because that's one standard deviation, but one standard deviation is 68%, but I only have half of that again, just like that last example. So all of the whole left is 50%. But this in here is 68 divided by 2 because it's only half in one direction, right? We're not going both directions. So this is 34%. So you can see that what I have shaded over here is going to be what's left over between 50, which is everything to the left, and what's in here. So that will give you 16%. Is what is shaded. Okay, so you're going to have to use some ideas. You know, it's not always going to be everything exactly in the middle where you might sometimes have to find these tails, and then you'll just have to subtract from 50%, that kind of thing. And the last one we'll do in this video is more than 100. So again, we have 70. Over here's 100. We want more than 100, and this is why it's so important to shade the region, because if you shade the region, then you can kind of decide, okay, I've got to subtract from 50, I've got to cut in half, that kind of thing. So 100 is 2 standard deviations from 70, and 2 standard deviations, the second number is 95. All right, but we know that this here to here, this is all 95, right, in between here. So again, we're going to want to cut that in half. So this is 95 divided by 2, so that was our 47.5 is what's in there. So we're going to use this 50% idea again. Everything to the right is 50%. So we know that this here is left over, what's left over, because in here this is 47.5. So what's over here is left over from 50%. Okay, that is the end of the first recording for this section.